Good day everyone. My name is Clarence Sagayno. I'm from Bachelor of Science in Computer Engineering 4-1 or 4th year first section, and I'm here to talk about a reflection paper or reflection video about how chip manufacturing and trends. So the first video is about chip manufacturing. Chip manufacturing gives a broad view, or the video itself gives a broad view of how computer chips are made. It explains that chip starts as pure slices of silicon called wafers. These wafers go through hundreds of highly controlled steps such as cleaning, layering, doping, etching, and testing to create billions of tiny transistors on their surface. Every transistor must be built with incredible precision, often smaller than a few nanometers, which is thousands of times thinner than a human hair. This video highlights how clean rooms must be almost completely free of dust, because even a single particle or substance can destroy an entire chip. That's how sensitive a single or multiple chips are. It shows that chip manufacturing is both a scientific and artistic process where engineering, chemistry, and physics all meet at a microscopic scale. The second video is all about why chip making is so hard. It's deeply interconnected with the first video, because the second video, which is entitled as Why Chip Making is So Hard, dives deeper into the reasons why producing chips is or is one or is the one of the most difficult processes in modern technology. It explains that the challenge is not just about making things smaller, it's about keeping everything perfectly aligned and defect free while working at atomic levels. The machinery used costs billions of dollars, and each step must be accurate to a fraction of a wavelength of light. Even the smallest mistake, like a minor vibration or a tiny variation in temperature, can ruin months of work in a single chip. The second video also mentions how expensive chip factories are to build and maintain, and how only a few companies in the world, such as TSMC, Intel, and Samsung, and a few more, have the technology and expertise to produce the most advanced chips. It makes you realize, or the second video makes you realize, that chip manufacturing is a global effort of precision, technology, and extreme discipline. So the usual chips on the past are usually bigger compared to the ones right now, but current technology improves the size of the chip to make it more viable and make it easier to store and make it smaller. That's about the second video. And the third video, which is entitled Photolithography. So photolithography focuses on one of the most important steps in chips making: the process of printing circuit patterns onto silicon wafers using light. That itself is very complicated, and a simple mistake on that process can make a chip, or it will definitely make the chip not work properly, or it will ruin the chip itself. This video, or photolithography video, explains that this is similar to developing a photograph, but on a microscopic scale, since the photograph is printed on a photo paper, as we all know. In photolithography, a chip a chip is made by using light and printing it on wafers, or silicon wafers. A special light sensitive material called photoresist is applied to the wafer, and ultraviolet light shines through a mask that contains the design of the chip's circuit. The exposed area hardens, and the unexposed parts are washed away, leaving behind the pattern of the circuits. This process is repeated layer by layer until the chip's full structure is built. The video also talks about how engineers now use extreme ultraviolet or EUV light to print even smaller features. Photolithography itself is essentially the heart of chip manufacturing. It's where ideas on a computer screen are turned into reality or real physical patterns on silicon wafers. That is the simple explanation of photolithography. It's basically a printing on or a photo printing, but instead of using photo paper, you use silicon wafers and you use also light. It's how chips are made. Next is the fourth video, and it is entitled as how CPU or central processing unit is or are made. So CPUs are made by it puts all the manufacturing steps together to show a central processing unit or CPU. And that is how it's created. It begins with chip design, where engineers plan the layout and logic of billions of transistors that will make the chip work. That digital footprint or blueprint is then translated into the physical patterns used in photolithography, or what's discussed on the third video. The fourth video also walks through on how those patterns are layered and connected with metal wires, how chips are tested, and finally how they are cut from the wafer or silicon wafers, packaged, shipped. And seeing this process makes it clear how much effort and time go into making something that we often take for granted inside our computer, which is the CPU, or our phones or our laptops. A modern CPU or central processing unit is the result of years of design, months of manufacturing, and incredible coordination between design engineers, material scientists, and fabrication experts. Since the past computers, as we all know, is very huge, one computer even has the size of a whole room, but it only does a limited amount of features compared to the computers right now. Since phones are also considered computers, it's very advanced compared to the past. And last but not the least is the last video, which is now entitled as Future Trends of the Computer Engineering Profession. So the last video looks ahead to the technologies that will define the coming years or the future. It discusses how computer engineering will continue to evolve alongside emerging trends like artificial intelligence or AI, quantum computing, and the Internet of Things or IoTs, robotics, edge computing. These technologies are all powered by increasingly advanced chips or processors. The demand for smaller, faster, and more energy efficient processors is shaping how the semiconductor industry innovates. Future chips will need to handle enormous data loads while consuming less power and space. The last video also points out how careers in computer engineering are becoming more interdisciplinary, combining hardware, software, and AI knowledge to keep up with these rapid changes. Technology is evolving throughout the years, so the computer engineering profession is very hard to maintain. So when we connect the 5 videos together, a bigger picture emerges about the present, the past, the present, and the future of technology. Chip manufacturing is not just another production process, it's the foundation of the modern digital world. Every smartphone, computer, robot, and AI system relies on these tiny pieces of silicon that holds billions of transistors. The process of making them is incredibly complex and expensive, but it's also one of humanity's greatest technological achievements. The challenges today is that we are approaching physical limits. Transistors are now only a few atoms wide, so manufacturers are exploring new techniques like 3D stacking or 3D printing. No, 3D stacking, never mind. Advances photolithography, and even new materials beyond silicon. But at the same time, future trends in computer engineering are driving even more demand for innovation and artificial intelligence, automation, smart devices, and powerful cloud systems. They all depend on the same thing, and they depend on more efficient specialized chips. As a result, the future of chip manufacturing will rely not only on shrinking transistors, but also on smarter designs, new architecture, and sustainable production methods. In conclusion, all the videos together from videos 1 to 5 shows that chip manufacturing lies at the heart of modern and future technology. It represents the perfect blend of science, engineering, and precision, enabling almost every digital device we use today. As modern technology keeps advancing, chip manufacturers will also face the challenge of creating faster and smaller chips while keeping them reliable and affordable. As the future of computer engineering will depend on how we continue to push the limits of chip design and production, making the impossible possible, one layer of silicon wafer at a time. That's my reaction video. Thank you for watching, and once again, my name is Josh Clarence Sagayno from BSCpE 41.